Hello, statistics student. This video is for chapter 1.2. We want to classify categorical data. So what are categorical data? The categorical data are cases where data values are names or label, right? For example, female, female, male, 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 etc., etc. So you'll be collecting gender, right? So the variable name is gender that you're collecting, and then these are the values. Another example would be you ask them if you agree with something or not, right? And so the data that you have, so this is whether your opinion of a particular um, issues, and then you can say yes, no, yeah, no, yes, or no opinion or whatever. So the data itself is not a number. They're labels, they're names, they're labels. So we want to summarize categorical data. Let me summarize all these. How do we summarize them? The easiest way would be look at the different category of the results, and then just tell people how many yes, how many no, how many in terms of counts. And in statistics, counts are also named as frequency and more fancy names. Um, and then other than the count, we also want to calculate the percentage. And in statistics, we use like in mathematics, we use a fancy word called relative frequency. But basically they are percentage. So that when we compare different data, we don't have to compare the counts, but we can compare the percentage, the fraction that belongs to a particular category. For example, and these relative frequency or percentage in general in statistics is called a proportion. That means how much percentage belongs to a particular category had in the whole population. No, not the whole population, in the whole sample data. It could be the population if you're collecting the whole population, but usually these are sample. So the first way to summarize data, so just imagine, so these are eye colors. So you would imagine data that you are collecting would be uh, a list of different colors, right? It'll be black, and then green, and then brown, and hazel, and then blue, right? All these are the data, actually the raw data. We call them raw data. And then after you summarize it by counting how many people have black eyes, how many have blue eyes. So these are the count of the data that shows up. Okay. So these are not the data values. So these are the counts. These are the summary. Okay. And these are the actual data, raw data, we call them, or the actual data. So after you have the count or the frequency, to make this more meaningful or useful, we would calculate the relative frequency, which is the percentage. To calculate it, first of all, you have to know how many data that you have totally. So what you can do is count all the counts, add all the counts together. So if I add 1 plus 4 plus 8 plus 2 plus 5, it amounts to 20 because this is 8 times 8 plus 2 is 10. 1 plus 5 plus 5 is 10, so it's 20. So out of 20, one person or one eye color is black. So you would say 1 over 20, and then change into percent is 5%. You can use a calculator to do it. 4 over 20 is 20%, right? And so this is 40%. This is 2 is 10%. 5 is 5 out of 20. 1/4 is 25%, right? So that is the relative frequency. Now, out of this relative frequency table, we can actually use it to understand the data better. So maybe you will ask, what percentage of student has brown eye or hazel eye color? They are similar. So what percentage had? So you will look at brown and then hazel. This is 40% and this is 25%. So you add them. So this 2% would be the total percentage that has either brown or hazel. 65%. What percentage does not have blue eyes? Blue eyes amounts to 20%. Not blue eyes would be what? All these others add together. Another way you can do is, so you can add 5, 40, 10, and 25, right? But the sum of all the percentage is supposed to be 100, right? So another way to do it would be 100% minus 20%. That's 80%. But it should be the same as adding 5, 40, 10, 25. Does not have blue eyes. So this is the use of the frequency table. We call it the frequency table. So other than summarizing categorical data in tables, we can also summarize them by graph. So there's three types of graph actually. The first two, bar graph and Pareto graph, are actually very similar. They're actually bar graph. The only difference is when you do a Pareto graph, the frequency. So basically, you graph something where the bar itself represents height. That is the frequency. So if a particular category occur more, you would have a higher frequency and you would have a higher bars. But so when you have a general bar graph, the frequencies are randomly arranged, usually arranged according to the order of the data. So if blacks shows up in the data first, like in the raw data first, then it would shows up first. But in Pareto graph, you order them so that the highest frequency go first. So basically, you rearrange this frequency table so that the highest frequency go first, so that you can say, oh, this is the highest frequency and this is the lowest frequency, instead of like scan around the bars to see which one is the highest or lowest. So the one where it is arranged in the descending order of frequency is called Pareto graph, and the one where you have all the frequency of each category showing up is called bar graph. One thing you want to notice is when you draw this bar graph, there's space between the categories. They don't stick together. One reason is, so if you have two population, like maybe you are recording eye colors for male versus females, you can have two bars under in blacks. One is male, one is female. Two bars, one is male, female for green. So those two bars will stick together because they are of the same category from two population. So in general, if it is from one population, they are all separated with space. And of course, if it is categorical data, you can also show data, summarize them by pie chart. So pie charts show the categorical data as slices of a circle. Usually it is a percentage, because a pie is 100%, like represent the whole 100%. And then you can just show, okay, so out of the 100%, how many is a certain percentage, like that. So we usually use to show composition of the whole. You can see that, oh, this is very popular to show market share. So, oh, this product has a more than 50% of market share. So it's very easy to see that it is more than half of the circle. Whereas if it's bar, it's hard to see that it's more than 50%, right? A bar graph is used to show relative differences between different category. A pie chart is to show composition, okay, of the whole. Now, in order to do a pie chart, your total frequency needs to be 100%. Versus if you just want to do a bar graph, you can say, oh, I don't care about certain colors. I just want to do the three colors. You can do that by showing the frequencies of those three. And the percentage is, less than 100% is perfectly fine, because you just want to show the relative difference. But for pie chart, you want to show things when everything add together to 100%. To create these, you can use a Google Sheets. In my Canvas pages, I have links to Google Sheets and also Google videos on how to create them using, raw data like this, which is useful when you're doing your projects. But in the meantime, the most important concept you need to master here is how to interpret a frequency table by answering these kind of questions. Okay. So the second thing we want to talk about, the third thing we want to talk about is types of sample and also sampling method. So I'm going to do a third videos on this. So would be yeah, I think we only have 5 minutes. I would not be able to finish all these. Okay, so it would be part 3 of 1.2.